Okay guys, so to make our physics fun catapult today, you are going to need some cardboard, a clothes peg, a medicine cup, some glue or a glue gun, or you could use masking tape. I obviously used a glue gun, you guys know that I love my glue gun. Some paint if you want to paint and decorate it, and some paintbrushes, and maybe a marker if you want to write something on it, and one sec. And yeah, one of these. And that's about all that you'll need to make your catapult with me today. So obviously this is my final product, my catapult. So you can probably see it's pretty simple to devise how I made it, but I'll talk you through how I made it anyway. So first of all, you are going to take your lollipop stick. Make sure it's clean and dry, otherwise it probably won't stick with the glue. Take your clothes peg. You can have different various sizes depending on how strong you want yours to be. I think that these plastic ones work better than the wooden ones, so choose as you wish, and whatever you have you can use. You're going to glue your lollipop stick on it like this, and you want to have a little bit of the end overlap off, and that's where you can press it with your finger to make it fire. So once you've glued that on, or sellotaped it on if you need to, you're then going to stick your your medicine cup, on top. So your medicine cup is your bucket where you place your load, your payload that you're going to shoot off. So you want to glue it on there, and you want to leave space for your finger at the top. Make sure that you glue it straight on. My one's not that straight, so it kind of fires off to the right a little bit, but you can play around with the placement of yours. Once you've done that, you can leave it like this if you choose, and you can hold on to this side, this bottom, as you fire it from this side if you like. But if you want to anchor it down and make it a little bit more stable, you can take some ordinary leftover cardboard like this. And I folded mine just a few times. I think it's 3 layers in total. And I just squashed it down and glued it. You could staple it, masking tape it, whatever you like. And then you want to secure your clothing peg to the cardboard so that you get a nice station that you can hold on to. So I can hold it from this side to fire it. And I've also got a little bit at the end that my finger can rest on. That's basically your full catapult right there. And I've just painted mine up to make mine look a bit jazzy. Now before we start to fire our catapult, what I want you to think about is the physics of how this actually works. So let me show you through a little demonstration and a firing of my actual catapult to show you how it works. It's all about the physics. So how does our catapult, our modern style catapult, relate to the original catapult that you're probably more familiar with? Well, let's have a think about the physics. The original catapult was invented in 399 BC, which is before Christ. So before Christian mythology became instated and before Christ was born. So it was used in battle by Greek soldiers, and that's who is assumed to have invented it. So it was a piece of equipment that they could transfer into battle, that they could use to demolish any structures or walls that were in their way of conquering the sites and the people that they needed to in battle. So it was a pretty important piece of equipment that was created in Battleland. And it was really strategically used too. So when we look at catapults, there are several different designs, but the one that we're going to be focusing on is called a mangonel. And I never pronounce it right, so I'm sorry if I pronounced it wrong, but it's called a mangonel. So our one is looking at our typical framework wooden catapult that you would have seen in commercials, in horrible histories and things like that. So when we look at our catapult compared to the older style original catapult, they're pretty similar. There are some things that are a little bit different. So here is my little diagram of an original catapult. So the similarities between ours and this original catapult are pretty stand out, like you could notice them straight away. So the original catapult had this projectile arm. We have ours too. It also had this bucket at the top which contained the payload, whatever they wanted to shoot into battle or into walls or castles or whatever they needed to. So ours also has a bucket, our medicine cup on top. It had this bottom framework and an A-frame as a support network. Ours has a bottom framework to anchor down our clothing peg, but it doesn't have an A-frame. We don't need that here because it's not as heavy. At the top of the original catapult, there was a crossbar as well. Now the crossbar acted as a way to limit the range of projection that our projecting arm had. We don't need that here, and that's something that you can play with when you do some little experiments with your own popcorn catapult. So, now the physics behind the original catapult is where it starts to differ from ours. The original catapult was made out of wood and rope, and so it had a little bit of a different, it needed to be used a little bit differently. So ours is smaller in size and it's made from plastic, wood and cardboard, which are fairly light and easy to find. Because this was large, it was the size of a car, maybe even bigger, you couldn't just pull it down with your finger like we do our projection arm. You had to use a system of ropes, pulleys, in order to lower the projectile arm towards the base to create that projectile force. So they had a restraining rope which pulled the bucket down to the frame. Now what pulled the bucket and the rope down to the frame is this mangle right in the center. So this mangle was like a big dial with a handle, and it had a series of twisted rope inside. So if you took a piece of cord and you pulled it really tight and then you twisted it up, when you let go it would twist back to the center, and it would do it with quite a large amount of force and speed. So that's what you need to think about when you think about this mangle here of twisted rope. It's acting almost like a spring which generates force and projects this arm forwards once the restraining rope is cut. There you go. So that's how it worked. So whatever was in the bucket load had to be pushed forwards and up. Once it reached the crossbar, it would be pushed out of the bucket that was connected to that projectile arm and be pushed forwards. Now there's a law of gravity, what goes up must come down. And whatever was in that bucket was pretty heavy. It was usually stones, crushed up rocks. So you could presume that whatever was being pushed up and forwards was really, really heavy. And so when it came down, it had a lot of force behind it. And that's where it was able to crash or break down walls, fences, whatever you needed. So that's how the original physics of a catapult works. So when you come to think about your catapult, there are a couple of energy storage mechanisms that are really in place here. We've got tension, torsion, and gravity. So tension, you can think about it as the rope that pulls the bucket down to the frame. Torsion is that central mangle or dial of twisted rope that pulls the projectile arm and the bucket load to the frame itself, and it generates a lot of force so that when the restraining rope was cut, the bucket flew forwards. Now gravity is the last energy storage mechanism that you need to think about, and that really is effect on the bucket load itself, what's inside that you're projecting forwards. Remember, what goes up must come down. And if you see this line here on my diagram, this is the route of travel that the bucket load would take. So it would be projected forwards from the torsion and the tension of the ropes here, and as the bucket load came up, almost horizontal with the crossbar itself, it would fling the contents of the bucket forwards. And as it came over, it would create this arc and start to travel forwards and down. And X marks the spot, and that's where they would be aiming to hit with their bucket load. So there you go, that's how the physics of an original catapult works. How does this relate to R1 and how does it work? Well, we don't have any ropes in us, but we do have this. So pressing your finger down into the projectile arm places the spring under a lot of tension and compression. This is what creates that projectile force that sends the bucket load, our popcorn, projecting up into the air, into that arc, and then gravity brings it down towards the ground. So our finger is producing a lot of pressure and tension, and that creates the projectile force. So once you've got your catapult made, you can do several different experiments with it to look at projection, to look at tension, how much force you place down on the catapult, how high does that generate a projectile force. You could look at loading it with different things so that the bucket becomes heavier. How does that change the projectile angle of what you're shooting out? So those could be some pretty interesting things that you could maybe try out with. You could create a little target like this. You could work on your target practice. So you place your target at a certain distance and you work on hitting bullseye. And you can create different scores. So each white one could be maybe 10, the purple ones could be 20, the green could be 40, the pink in the middle could be 50, I don't know. So you could do something like that. You could also get some toilet roll tubes, cut them in different heights, and you can layer them in as well. So if you get them inside the smallest tube, you get a bonus. In the larger tube, you get an even bigger bonus. So you can do stuff like that. But my favourite by far is playing with a friend. I'm loading my catapult with popcorn because it's the perfect size, it's really light, so it flies really far, and plus you can eat it. So what if, 2-person game, maybe even 3 or 4, you load up your catapult with popcorn and you try to attempt to shoot it into someone's mouth. Or you shoot it and they have to try and grab it in their mouth. Those could be quite cool, fun games you can play at home whilst you've got tons of time on your hand. Have a go with my fun catapult, popcorn catapult, and let me know how you get on. I really love to see you guys embracing your physics, your science at home whilst having fun. See you next week.